Okay, just imagine this. NASA has confirmed a third interstellar object. I mean, a visitor from another star system just zooming right through our cosmic backyard.
It's pretty incredible.
It really is. It's frankly astonishing and, a truly rare moment in astronomy.
Absolutely. And that's exactly what we're diving into today. We want to unpack what this extraordinary object is, where it came from, and why its discovery is just so pivotal
Right.
for how we understand the universe, basically. We'll be pulling insights from the Science Alert article and looking at what astronomers like Jonathan McDowell, Richard Moyes, David Rankin, and Mark Norris are saying.
Okay, so let's start with the big reveal then. What exactly has been confirmed here, and why is it such a big deal?
Well, the confirmation is for a brand new, officially designated interstellar object. It's called 3 Atlas.
3 out.
Yeah, and the 3I literally means it's the third interstellar object humanity has ever spotted. It got named by the IAU's Minor Planet Center. They're the official group for naming and tracking this stuff. So that designation alone, 3I, really highlights how rare this is.
And where did this cosmic newcomer first pop up? Where did we spot it?
It was actually the NASA-funded 8TLS survey in Hawaii. They picked it up first on Tuesday, July 2nd, 2025.
Right, ATLS.
Yeah. And it got attention pretty quickly, partly thanks to a Bluesky post from U.S. astronomer David Rankin.
Ah,
And from there, its trajectory was so distinct that astronomers could trace its path back to at least June 14th.
wow, so they corrected backwards in time, essentially.
Exactly. And before they knew for sure it was interstellar, it had this temporary name, A11KL3Z.
I catch you one.
Yeah, just a catalog designation. But what's also really interesting about 3 Atlas is its classification. It's a comet.
A comet, yeah.
Yeah, Jonathan McDowell, he's at the Harvard-Smithsonian Center for Astrophysics. He noted and I quote loosely here, "The fact that we see some fuzziness suggests that it is mostly ice rather than mostly rock."
Huh. Fuzziness means ice. So given it's this frosty comet, how does that play into its size? We're hearing estimates like, 10 to 20 kilometers wide? That sounds huge, potentially the largest one yet.
That's the current thinking, yes. That 10 to 20 kilometer range makes it likely the largest detected so far.
Right.
But the composition is really key. As you said, it's icy, so it could actually be on the smaller side of that range.
Oh, why is that?
Well, simply because ice reflects more light. So something icy can look bigger and brighter from far away than a rocky object of the same size. It's a little nuance in how we figure these things out.
Got it. That makes sense. Now, you mentioned its trajectory earlier.
Yeah.
What's truly captivating here is its speed, right? And its path through our solar system. How fast are we talking?
The speed is just astounding. It's zooming along at more than 60 kilometers per second.
60.
Yeah, that's about 37 miles per second. This incredible speed is, it's the smoking gun. It confirms it's on a hyperbolic trajectory, meaning it's not gravitationally bound to our sun. It's not orbiting like our planets or, most comets and asteroids we see. It's just passing through.
It's visiting.
Exactly. Completely different dynamic from objects born in our own system.
And Richard Moisel from ESA, the European Space Agency, he commented on its path, didn't he, saying something reassuring?
He did. He stated it will fly deep through the solar system, passing just inside the orbit of Mars. But importantly, he clarified it poses no threat to Earth.
Phew. Okay, good to know.
Definitely. And Moisel's point really underlines its nature as a visitor. He said its trajectory means it's not orbiting our star, but coming from interstellar space and flying off to there again. A true wanderer.
So it really makes you wonder then, where did these things come from? How does an ice ball get kicked out of its home system and sent wandering the galaxy?
Jonathan McDowell had a great way of putting it. He explained something like, we think that probably these little ice balls get formed associated with star systems.
Okay, so they form like our own comets around a star.
Right. And then, he said, as another star passes by, tugs on the ice ball, frees it out, it goes rogue, wanders through the galaxy, and now this one is just passing us.
Like cosmic pinball almost. A gravitational nudge sends it flying.
Precisely. A cosmic game of billiards, maybe? Gravitational interactions just sending these things careening across interstellar space.
Fascinating. So for anyone listening who might have access to a Sirius telescope, what's the window for observation? Can we still see this thing?
Yeah, good news on that front, for astronomers at least. It's expected to get brighter and closer to the sun until late October.
Okay, peak brightness around then.
Exactly. And then it should still be observable by telescope until next year. So there's a decent window.
And where is it right now, roughly?
Currently, it's roughly around the distance of Jupiter from Earth. So still quite far out, but getting closer.
Okay. But are there challenges in observing it, even with good equipment?
There are practical challenges, yes. Mark Norris, he's at the University of Central Lancashire, pointed out that it's currently only visible in the southern hemisphere.
No.
Which means, as he noted, he couldn't observe it from the UK, for instance. So that geographical limitation is real. It often takes coordination between observatories worldwide to get continuous data.
Right. And given its speed and trajectory, is there any chance, realistically, of sending a space mission to, like, intercept it, fly alongside it?
Richard Moisel addressed that pretty directly. He said it's not feasible to send a mission into space to intercept the new object.
Not feasible. Just too fast. Too far.
Basically, yeah. The sheer delta V, the change in velocity required to match its speed, and the pinpoint accuracy needed for an intercept within the time frame.
Yeah.
It's just, well, beyond what we can currently scramble together quickly.
Right.
It really highlights how fleeting these encounters are. They zip in and zip out.
And this isn't our first interstellar visitor, as we said. We had Oumuamua back in 2017.
Ah, yes, Oumuamua.
Which caused quite a stir, that initial speculation about it being, an alien artifact.
Which was later dismissed, of course.
Right, dismissed. But it was exciting. And then there was 2I Borisov in 2019, which was more clearly a comet. How does this new one, 3I Atlas, stack up against those two?
Well, one key difference Mark Norris pointed out is its speed. He noted that 3I Atlas appears to be moving considerably faster than the other two extrasolar objects that we previously discovered.
Faster even than Oumuamua and Borisov. Wow.
Yeah, so it's not just the third visitor, it's apparently the fastest one we've clocked so far among these interstellar guests.
Okay, so stepping back, what does this all mean? We've spotted 3 now. Does that tell us anything about how common these objects might actually be? Are there loads of them out there?
That's where it gets really interesting. Mark Norris has done modeling on this, and, well, it's kind of mind-blowing.
Oh, yeah.
He estimates that there could be as many as 10,000 interstellar objects drifting through the solar system at any given time.
10,000 right now.
At any given moment. Now, he does add that most of those would likely be smaller than 3 Atlas, harder to detect.
Still 10,000. That just completely reframes how we think about interstellar space, doesn't it? It's not empty. It's full of these drifters.
Exactly. It suggests interstellar space is maybe more crowded, or at least contains more of this kind of debris than we might have thought.
What does that imply for actually finding more of them, especially with new telescopes coming online?
It has huge implications. It suggests that the Vera C. Rubin Observatory in Chile, the one that's just starting its survey,
Yeah, the big new one.
with its incredibly wide field of view and sensitivity, it could soon be finding these dim interstellar visitors every month.
Every month.
Yeah.
Seriously.
That's the potential. Based on these kinds of population estimates, we could be shifting from these being, once in a few years discoveries to almost routine observations.
Wow, that would be a whole new era for studying material from other stars.
Absolutely.
Which brings us to the big question, I suppose. Why should you, listening right now, care about 3I Atlas zipping past Mars? What's the real takeaway here?
Well, connecting it to the bigger picture, these visitors, they offer scientists a rare chance to study something outside of our solar system. Up close, relatively speaking.
Okay.
I mean, think about it. We don't have to launch a probe billions of miles away, which takes decades or centuries. The universe is kind of delivering samples right to our doorstep.
Crystals of other star systems.
Exactly. Direct insight into the materials, the chemistry, the building blocks of planets and comets from other stars. It helps us understand how common our kind of solar system might be, what variations exist, things we couldn't know otherwise without actually going there.
It's like cosmic archaeology almost.
Yeah.
Studying relics from distant places.
That's a good way to put it. And perhaps the most profound question these objects might eventually help us tackle.
Go on.
Could they tell us anything about the potential for life beyond Earth?
Ah, the big one. How so?
Well, this raises that critical question. Mark Norris put it very well. He said that if we detected precursors of life, such as amino acids on such an object...
Like the building blocks of proteins.
Exactly. If we found those on an object that we know came from another star system, it would give us, and this is his quote, a lot more confidence that the conditions for life exist in other star systems.
Wow, because it would mean those basic ingredients aren't unique to our solar system.
Precisely. It would suggest the raw materials for life might be widespread in the galaxy. It's a really tantalizing possibility that these interstellar wanderers could carry clues about the prevalence of life itself.
What an absolutely incredible discovery then. And just the third one. It feels like each time one of these passes through, we learn so much more. It's a constant reminder of how dynamic the cosmos is.
It really is, and it leaves you wondering, doesn't it? What other secrets are these objects carrying from distant stars? What will the next one tell us? As we find more, potentially every month. How will that expand our view of the galaxy's, hidden life and its dynamics?
Yeah.
It's like the universe keeps sending us these fascinating little postcards from places we can currently only dream of visiting.
Okay, just imagine this. NASA has confirmed